Good morning, everyone. And this first webinar from MegaPrint on printed electronics, we are very happy to have you here today, and we will be your hosts for the next 30 minutes.
Yeah, hello. My name is Patrick. I've been working at MegaPrint as development and project engineer for 4 years, and I have a background with a PhD in physics.
My name is Anders. I've been working with printed electronics for the better part of 8 years here at MegaPrint in a role as a key account manager. Just some practical information before we start. We will finish off today with a short Q&A session. So if you have any questions or any questions arise during the webinar, you can type them into the Q&A module in the top right corner. And then we'll try to cover all of the questions at the end of the session. If for time reasons there will be some questions we can't fit into the time schedule, then we'll get back to you by mail after the webinar. Also after the webinar, you will also receive a link to a recorded version so that you at any time can go back if there are some points that you would like to revisit. And you also have the opportunity to share the link internally with your colleagues if you like. So this webinar will be the first in a series of webinars. Today we'll be focusing on some basic essentials when talking about printed sensors in terms of typical building blocks. In the coming webinars, we would like to zoom a little bit more in on specific technical areas and specific sensor types. However, here at MegaPrint, we are a completely customer-driven company. So we are very interested in hearing from you if you have some ideas on topics that could be of interest to incorporate into one of the future webinars that we'll be hosting. So please feel free to share any thoughts with us. Here is the agenda for today. We'll start with some context and background on why we think printed electronics is a very interesting area. Before Patrick will go a bit more technical, first he will go in with an introduction and some considerations on general building blocks for printed sensors, and then with an evaluation on different printing technologies that can be used. Before we go into the Q&A session, to finish off for today, we will give a very short outline on the printed electronics side of MegaPrint. So let's start with why we think printed electronics is a very interesting area. So as a screen printing company, MegaPrint has been a leading supplier in the area of printed electronics for many years by now. And we've seen a dramatic increase in interest on different levels, both from a technical and from a market perspective. From the technical perspective, there's been a lot of development and a lot of focus on what can we achieve with printed electronics and how far can we push what we can actually print and on what we can print. And in this regard, there's been a lot of discussions focusing on possible printing actual electronic components directly onto a substrate. That could be capacitors, resistors, LEDs, etc. And as a way of either omitting or at least reducing the size of the PCBAs. MegaPrint is mainly an industrial high-volume printing partner. So we of course support early development of new products, but we have a core focus on industrial mature technologies for actual market applications. So that also means that the webinar, once we go a little bit more technical on the building blocks, that will also be our focus in this webinar. So if we look at it from a market perspective, then over the years, we've seen a very, very big increase in the interest to use printed sensors from many different segments in many different application areas. And to give you some examples of that, I think we saw years ago within both major appliance and later on in automotive as well, user interface technologies were dominated by physical and more tactile buttons. But I think with a consumer desire to transition a little bit more towards a smartphone-ish kind of smooth user interface. And in that regard, a printed capacitive touch sensor is a very low-cost alternative for an off-screen user interface where you can get this more smooth user interface that is more prevalent in the consumer world today. We've seen the same tendency in HVAC products. For example, when you have room thermostats, we see that also going more and more to capacitive touch user interfaces. Another area that is super interesting is the healthcare market. We've seen a very, very big increase in the interest from very many different type of applications in this area. And I think especially since COVID, and as a way of taking some of the pressure off the healthcare system, we've seen a big increase in interest in developing solutions that can support remote diagnostics and remote rehabilitation, and as a part of this wearable technology wave, and as a way of incorporating printed sensors into different solutions. Printed heaters is another topic and a technology that is becoming a big topic in the printed electronics industry. This could be both resistive heaters or self-regulating PCC heaters. Again, if we look at the automotive, there is a lot of surface space inside a car that do not necessarily have any specific smart functions today. And there's been a very big drive in that industry to try to see how you can incorporate smart functions into these different surfaces. And a printed heater is one way of doing that. I know especially here in the Nordic part of Europe, where it tends to get quite cold, we like to have some heat incorporated in our cars. So we know, of course, heat in the seats, but it could also be in door panels or in dashboards and roof modules and so on. Another area for printed heaters that is very interesting at the moment, I think, is also with the transition more and more towards electric cars, where batteries, of course, and the performance of batteries is a big topic. We see more and more at domestic and industrial buildings that battery packages are installed. And it is a big challenge for batteries to perform under cold conditions. So printed heaters is also here a very interesting technology and a topic that is looked into as a way of increasing the performance of batteries. The last area I want to mention, there's of course many different interesting areas, but there's an area that we call smart home, and that basically covers many different types of technologies. But we've definitely seen a big increase in interest for different sensors that can help detect moist in a building. For example, sensors that can go underneath the roof or behind tiles and surfaces inside the house to help remote detect if there is a leak, either in the roof or in a wet room in a home. Instead of having to break everything up to try to identify the leak, then that can help to remote detect if and where there is a leak. We also see it maybe a little bit more on an industrial level. For example, in nursery homes, we've seen some desires to try to incorporate fall detection sensors under the floor to help detect if an elderly person is active in an area or has fallen in an area where it's of course not desirable at a given point of time. So overall speaking, from a market perspective as well as from early development, there are many possibilities with printed sensors and the developments that are going on a technical level. So with that, I would like to hand over the word to Patrick so he can go a little bit deeper into the building blocks of a printed sensor.
Yes, thank you, Anders. So, how do you plan and design when you want to make a printed sensor? So there are many different options and materials available, so we don't have a one-size-fits-all solution. It will, of course, depend on the functionality. Like it's a different solution for a touch sensor, a capacitive touch sensor for white goods that's fixed once mounted, compared to a resistive healthcare sensor that's wearable and needs to be stretchable. So requirements for flexibility, stretchability is one of the things that needs to be considered. Other points of consideration could be optical properties like transparency or light blocking. How about a graphical design? Are there any specific requirements for conductivity, sensitivity, as this will influence how thick the printed layers need to be? A very important consideration is how you're going to connect it into your system. Is it going to be a SIF connector, a clip, or a completely different solution? So in general, we would like to be involved very early in the process so we can provide inputs to the design and consider design for manufacturing approach from the beginning so the sensor will be produced efficiently. So there are many ways to build a sensor, but we'll go through some of the typical layers here to give you a rough idea of what is possible. It will always be your specific projects and demands that defines the final design, so it will be a customized solution that meets your requirements. But first of all, we need a substrate to print on. This will typically be a plastic like PET or polycarbonate, but it can also be a more stretchable material for healthcare sensor like TPU. Then we'll usually print some lines or wires in silver. So you can say this defines the electrical outline or the general functionality of your sensor. Onto this, we can add an additional conducting layer. So this could be a transparent conductive layer for adding touch functionality, or it could be a silver chloride for a healthcare sensor. It really depends on the application. Then we often print a layer of carbon. It can both add some additional functionality to the sensor, but at least we use it to cover the silver in the connector region to avoid oxidation and just to provide some strength here. In the connector region, we can also add a tail stiffener. This can both add the correct fitness, so it fits straight into your connector, and it is also to add some additional robustness in this connector region. In many applications, it's also a requirement that the conducting layers are sealed or protected from the surroundings, so a dielectric layer can be added as well. This can will usually be a printed dielectric lacquer, but it can also be a laminated cover foil. If necessary, we can also print and add a graphical design. This could be for highlighting some buttons. It could be for adding a logo or company name, or adding some other important functionality or information like a product number that's needed on the foil. Finally, we often add an adhesive, usually by lamination, for bonding the sensor to your device. So this could be a plastic molded part, for instance. So these are some of the typical layers that goes into a printed sensor. So at MekoPrint, we see ourselves as a partner in scaling your production. So after you've made proofs of concepts, then we're ready to help you with maturing the product. So we prefer to be involved as early as possible in the process, so we can make sure that design for manufacturing is considered, and you end up with a sensor that's efficiently produced and works straight away in your ecosystem. So we can deliver a sensor based on your design, but there are lots of processes around the sensor that also needs to be ready at the same time. So this is both the IT infrastructure that surrounds your solution, it's knowing how your users interact with your device, and then it's the very important interface between the sensor and your setup, which is the connector and the corresponding electronics. So all of this needs to be in place to make sure that you end up with a solution that works. Now, if we take a step back again, then what we know something about is how to produce a printed sensor. And we would like to present some options for such production here. So there are many different options for producing printed electronics, and they all have their different advantages and drawbacks. So what we would like to do is to give a broader overview of some of the technologies that are available, and not just what we do here at MakerPrint. So we have found some different production technologies and would like to compare some of the features here. It's very important to consider the production technology early in the development, as these choices can impact the sensor functionality, like the conductivity, sensitivity, but it can also impact the cost, the price of making changes, and just impact your general possibilities for scaling the production. So the technologies we compare here are screen printing, as we do here at MakerPrint, where design is printed by squeezing an ink through a patterned mesh. We mainly do roll-to-roll screen printing, but it can also be done in a sheet production, which we also do here, for instance, for prototype production or smaller batches. Then there's inkjet printing, which is a very direct fabrication method that can especially be good for prototypes, maybe less well suited for mass production of big sensors. And here we're speaking of functional inkjet printing, not black text in a continuous inkjet printer. Then there's flexographic and gravure printing, where the image is transferred by a cylinder, which makes it possible to print thinner layers fast. And then finally, we've put in slot die coating. So this is more a coating technology and not directly a printing. And this is maybe better for large surfaces. So the parameters that we're comparing are the feature size. So for a sensor, this could, for instance, be the line width of your silver traces. So for all the printing technologies, you see you can print quite fine details, while coating is better for larger features. Then there's the printing speeds. How fast can you produce parts? This will vary a lot depending on specific sensor requirements, but it is of course slower with sheet-based printing production, and the same with inkjet printing. Then there's the layer thickness, the thickness of the printed layer, and this can be very important for specific technical and functional requirements like conductivity, sensitivity, light diffusivity or opacity, or the strength of a dielectric layer. The layer thickness, together with the ink viscosity and the printing speed, to some degree goes hand in hand, as printing a thicker layer of silver requires a more dense ink, which again requires more heating and drying capacity. So it will just take longer time compared to a very thin graphical layer where the solvent can quickly evaporate. Then as the final feature, we've put in the cost of stencil, and here we define the stencil as the material that transfers your design to the substrate. So this can influence the cost of getting started, and it will influence how easy it is to make changes along the way to your design. So for inkjet printing, this is a digital file, whereas for flexographic printing, it's a flexible printing plate made of rubber or polymer, and then it requires engraving a metallic cylinder for gravure printing. So it's quite different how it is to set up these productions. Also, bear in mind that all the values we show here are typical values, because it will vary a lot depending on the specific design, the layer thicknesses, and also the remaining production setup, including the curing and drying capacity of a printing line. So there are a lot of things to be considered. So therefore, we'll try to give a comparison of the printing technologies with a focus on the parameters that we believe are important for sensor and electrical functionality. So we've tried to make a plot that shows how the production technologies compares when looking at layer thickness and feature size. So first, slot die coating is good for coating big homogeneous features. And if this is what you're looking for, you could look into coating technologies in general. In the other end, we have inkjet printing, which is good for easy prototyping with fine details. And then if you need speed and thinner layers, you can look into gravure printing or flexographic printing. At MakerPrint, we use roll-to-roll screen printing, with the option for prototypes in a cheaper sheet-based setup. And we find this to be the ideal solution if you have fine details, but also need a specific layer thickness for your sensor to work, and also the ability to get started and make changes at a relatively low cost. So let's dive a bit into screen printing, what we do here at MekoPrint. So we work with this production technology for several reasons. Generally, we find that it's an ideal technology for mass production of printed electronics. It's a technology that allows high automation, which enables low cost and high uniform quality, and the ability to produce complex structures. And at the same time, we can print quite thick layers, which makes it possible for us to tune important technical parameters, like for instance, conductivity. So how does the process run? What you see on the image is a picture of a patterned mesh that's used in a production line. So this mesh is tensioned across a frame, and then we apply a photosensitive emulsion to the mesh, and through a lithographic process, we can develop your design on the screen. So an example of design is what you see in yellow squares on the image, and then we only squeeze ink through the mesh in these desired patterns. So this frame is really where the magic happens. And there are a lot of options and therefore complexity in choosing the correct mesh, the tension, the optimal printing parameters, and so on. But we're experts in this, and we'll make sure that we have it set up in the best possible way that fits your product. So if we go in and have a look at a production line, then it could look something like this. So here we have two printing sections next to each other, and there's a third section further down the line. So what you see is that roll-to-roll screen printing is a very dynamic process. So we have a continuous production where the substrate roll and the frame is always moving while squeezing ink through the mesh in your desired pattern. So this gives a very high level of efficiency. For those who are not familiar with screen printing, then we need one screen or frame for every layer that has to be printed. So here it's a silver print for a sensor, and then after printing, it runs down through a heater system below to be cured before the next print. So then after it's been cured, it comes out the next printing section. So here the second print is a transparent cutting layer that's printed onto the silver that was printed first. So we position this print based on some register marks made in the first print, so all following layers are perfectly aligned to each other. And then depending on the required number of layers in the final stack, the roll can run through the machine several times to add dielectrical layers, graphical prints, and so on. And that's how the final sensor is built up. So after printing, we also have roll-to-roll conversion options for lamination of adhesive, die cutting into specific shapes. And we also do have automated optical and electrical testing available in-house to make sure that we deliver functional sensors that meet your requirements. So after this quick look into our production, back to Anders, who will highlight some of the core competencies that MekoPrint stands for.
Thank you, Patrick. Yeah, so just before we go to the Q&A, just a short outline of the printed electronics side of MekoPrint, and maybe a little bit background for why we are having these printed electronics webinars at all. So I know some of you already knows us, but in short, then MekoPrint has been in the market for printed electronics for many years. Both as a development partner, but especially as a maturing and scaling partner for high volume production of printed sensors. We have a relatively big team, both from educated printers in our production to the development engineers like Patrick, and they work on a daily basis, both on developing new designs as well as with what we call lifetime engineering. Because everything that we help to develop goes into serious production. So with lifetime engineering, what we're really trying to look into here is how we can robust and optimize both together with customers on the design, but also from a process perspective. So it's never just just pouring projects into series production, but we work with it continuously to see and look for optimization possibilities. When we start a project together, we see it more than just a transactional business relationship, and we see it more as a more tight-knit partnership on many fronts. So that also means that we tend to work with our customers for many years when we go into a collaboration. We supply to many different industries and many different applications, and that also means that when we are looking and evaluating a new project, we take all of that accumulated knowledge from supplying to and working together with demanding customers and demanding industries with a lot of different requirements. So all of that accumulated knowledge we can bring into play when we evaluate and work on a new project in a given segment. Having said that, all projects are of course individual, and each sensor is customized for every project and every customer. And to support that in the best possible way, one of our core values here at MikroPrint is to be curious. And we want to be curious together with our customers and our partners in general, because that enables us to have the best understanding on both sides. What are our capabilities, and more important for us, what are your requirements? How does the sensor fit into your product, and what is important for you? And by having that more holistic approach together, that's at least where we find that we end up with the best solutions, both from a technical, but also logistics and so forth. So that's very important, and an important way of how we like to work together with our customers. So that was, in short, a little bit about the printed electronics side of MikroPrint, a little bit about the context and background for why we think printed electronics is an interesting area, and a little bit about the different building blocks and printing technologies that can be utilized when you design a sensor. To finish off, we will now go to the Q&A. So if you haven't had the chance yet, then you are more than welcome to type in questions into the Q&A module, and we'll try to cover them now.
I can also see time is almost running out already. We'll take a few questions now. If you don't get through all of them, we'll make sure that we get back to all questions in written form afterwards.
So there's a question here. Can you advise on connector requirements based on material stack up? So that is a little bit getting back to one of the critical topics about the connection. And in general, as Patrick mentioned, we see a lot of different types of connection possibilities. Some of the more mature technologies, like for example with capacitive touch, we see a clear tendency to use different types of SIF connectors. Whereas when you look into the healthcare segment, there is a very widespread use of printed sensors in many different types of applications, and we see a lot of individual customized solutions for how the sensors are connected. So we can to some extent guide a little bit on this, but I think one important factor here is that the connector needs to fit within your specific solution. So that can make it a little bit difficult for us to be recommending specific technologies in this regard. So we can maybe take this one.
Yeah, let's try.
There's a question here. What is the best carbon ink for connectivity at low resistance requirements?
Yeah, so I think we work with many different providers of raw materials. So I don't know if we have one best carbon ink. It also depends on the specific application and the substrate that it's being printed on, and the curing requirements of the substrate. So we don't have one go-through material, but of course we have some different materials that we know work well and we can help you with recommending some of these particular materials.
We can maybe take this one here. What is the general thickness of a full stack-up of a capacitive touch sensor?
Yes, this is also it's a very good question. It also varies a lot because, as we said, there's not a one-size-fits-all. So first of all, you have the thickness of your substrate. This will usually be 125 or 250 microns thick. And then the thickness of the individually printed layers is usually a few to 10 microns each. Then you add an adhesive, and then you'd often be maybe around 250 microns in total on a thinner substrate. But yeah, it also depends a lot on the printer and whether you need a dielectric layer and whether you need an adhesive in your sensor.
Yeah. So I think the tendency in many of the answers is that there are a lot of different type of solutions to the different challenges, and it all very much depends on the actual application. There was one more question up here that I would like to bring up. Again, about the connectors. So what type of connectors are appropriate for this technology? And I think maybe we answered it a little bit before, but again, for example, in the applications with capacitive touch, we see a tendency to use different types of SIF connectors with a different pitch sizes, but that seems to be the go-to for capacitive touch, where the SIF connectors are directly on the PCBA. If we again maybe look into the healthcare segment, we see a wide variety of different type of connection methods. Some customers are using spring-loaded connectors, some are using snap button connectors, some are using SIF connectors as well. And then again, we see some with an FPC tail type of connector on the sensor, and where they have then developed like a clip-on connector to go onto the sensor, and which can then be reused again, so that the disposable part of the product becomes the sensor, and the hardware and the connector part can then be reused multiple times. So there are a lot of different opportunities depending on what, again, is the most suitable for the specific project. But we see a wide variety of different connection types being used in general.
I think we can maybe also just quickly relate this to the question before about thickness. So as you said, then the sensor can have one thickness, and then we can add a tail stiffener in the connector area to give this a specific thickness that fits straight into your connector, but doesn't influence the thickness of the remaining sensor.
Yeah. So Patrick, I think in respect for the time, I can see that we have now passed the half an hour by a few minutes here. We will be looking into all of the questions, and I think that we have the contact information of each one of you. So we'll get back to you by email to answer these questions after the webinar. We will be coming back later with more information on future webinars. And again, if you have any interesting topics that could be incorporated into a webinar, please let us know. We'll be happy to evaluate it. For now, I think we would like to thank you for your time. And thank you for your interest in printed electronics and printed sensors. We hope that you have gotten at least a little bit of inspiration around what constitutes a printed sensor and some of the considerations that are important when you are developing a printed sensor for your product. Thank you very much for your time, and have a great rest of the day.
Yeah, bye for now.
Bye.